Mr. Berry transferred 1200 joule from his body to the box, so the box moved 40 meters to the right. Good afternoon, everybody. In this video, I'm going to go over homework number 11, and it is very important for you to understand this concept, is because tomorrow I'm gonna give you RQ assignment based on this assignment. So please watch this video as many times as needed to fully understand, fully grasp this concept. So let's get started. So our goal is to find how many mistakes in this problem. So only one way we can find it if we read the problem. So let's read the problem. So the problem is, there is a box. There is a 50 kilogram box, and Mr. Barry want to move this box from location A to location B, which is 40 meters away. Now, Mr. Barry knows that he needs to put some energy in the box so that more boxes start moving, but he cannot just put the energy to the box. So he decided to apply forces in the form of pulling it by a string. So he pulled the box 37-degree angle. He applied 100 Newton force to the box. So he gives some energy to the box by applying some 100 Newton forces at 37-degree angle. So how much energy did he give it to the box? Well, about 1200 joule. How did he give 1200 joule? Just like that? No, you cannot throw the energy. You cannot throw the energy. Someone thought that he is my grandpa. No, my grandpa. He's not my grandpa. He is James Prescott Joule. And James Prescott Joule taught us that you just cannot throw the energy. You cannot just throw the energy. You have to transfer the energy. How can you transfer the energy? By force. By force, how much energy did Mr. Barry transfer to this object? So this object moved only 40 meters. Well, Mr. Barry, that is right. Okay, Mr. Barry applied about, Mr. Barry transferred about 1200 joule. How much energy did he transfer? He transferred about 1200 joule. From where? From his body to the box. So the box moved how much? The box moved 40 meters. So that's the problem. So once you understand the problem, then you have to start reading it, and only reading it you can catch the mistake. So let's start reading. So we choose our coordinate system so that x can be the vector that represents the 40-meter displacement that is along the x-axis. In the class, sometimes I talk, sometimes I use d for displacement. In this case, I use x because James Prescott Joule used x 1840, long time ago. Okay. Three forces. I caught fast mistake. Three forces. There are not three forces. There are actually four forces. There are actually how many forces? There are four forces. So fast mistake I caught. So I'm going to put a number. Mistake number 1. So there are four forces. So what are the forces? Let's find out. So this is the box. Well, let's draw a really box. This is the box. 50 kilogram box. Four forces. Let's read the all four forces. Hopefully they are given. The force exerted by the man. By Mr. Barry, force exerted by the person, so by Mr. Barry. So how much force Mr. Barry exerted on the box? Wow, not 100 Newton, not 100 Newton. 100 Newton does not contribute to the work. Only 80 Newton contributed to the work. You're gonna find out why. So Fx, only 80 Newton. Fx is 80 Newton, by the way, 80 Newton. What else? The friction force. Wow, friction force. And how much is the friction force? How much is the friction force? Ff is 50 Newton. Ff is 50 Newton. What else? The gravitational force. Of course, there is a gravitational force. Gravitational force is how much? If this is a 50 kilogram, gravitational force is 500 Newton. And of course, the normal force. But you probably think that the normal force would be 500. You'd be wrong. Normal force would be 440 Newton. Why the normal force 440 Newton? Think about it hard. You may figure it out. Okay, 440 Newton. All right, let's make it a little smaller. Let's make myself a little smaller so that you see full information. Okay, let's go ahead. So far we found only one mistake. Okay, the work done by gravitational force and by normal force is 0. Of course, the work done by gravitational force and normal force is 0. Why? Let's put the displacement vector. So this is the displacement vector, which is green. Let's put the x. acts as the displacement. What is the relationship between displacement and normal? 90 degree. The purple and the green is 90 degree. So work done by normal force is 0. And what is the relationship between this the green and the dark, which is the gravitational vector, and that's also 90 degree. The relationship between this one, and this one is 90 degrees. So work done by gravity is also 0. Get it? Okay. The next thing we're gonna do, we see this is correct, this looks correct. All right, no problem with this one. But there is a mistake we catch over here, because sine 90 is 1, so it's not sine 90. Because the normal force, the purple and green, is not sine 90, is actually cosine 90. So that should have been cosine 90, not sine 90, cosine 90. So there is a second mistake we caught. So mistake number 2. Let's circle it by red. All right, let's keep going. So we see that the work done by the person at the x direction is 50 times 40. So we see that the work done by the person 100 times 40 times cosine 37, that would be well, if we do only 100 times cosine 37, that would be 80 times 40 is 3200. So that's good. And this one is negative 200. That's good. So the angle between the displacement and the friction is 90 degree. No, that's not true. So we caught another mistake. We caught another mistake right here. So angle between the displacement and friction, so the friction is blue and the displacement is the green, and there is an angle between this blue vector and this green vector, and angle is 180 degree. So there is another mistake, 180 degrees. So we see that there is a third mistake. Okay, great. Okay, so the work done by friction on the box is negative. Of course it is negative. So the net work can be calculated in 2 equivalent ways. So I'll show you the first one and I'll show you the second one. The second one is just the simple approach, is using Newton's second law approach, and the first one is work approach. So as I said, work done by gravity is 0, work done by normal force is 0, work done by this one is 3200, and work done by this one is negative 2000. So total work done is 1200 joules. So what happened? Mr. Berry transferred 1200 joules from his body to the box, so the box moved 40 meters to the right. Thank you for watching. By the way, how many mistakes we found? 3 mistakes, but that doesn't matter. The matter is whether you understand the problem. Thank you for watching. Again, keep watching this video until you grasp the whole concept.